Number 1, in the sequence below, which expression can be used to find the value of the term in the nth position? And let's recall that n in our answer choices stands for position. Let's take a look at the table. So in the first position, we have the number 0.25. In the second position, we have the number 0.5. The pattern is the numbers are increasing by 0.25 each time. And if you can't identify the pattern, what you want to do is take the first two numbers and subtract them. So take 0.5 and subtract 0.25. Add a 0 here. You have to borrow. And sure enough, you end up with 0.25. And don't forget, when you're subtracting decimals, you line up your decimal. And then we can see if the pattern continues by subtracting the last two numbers. So we have 1.25 minus 1.0. And we can see that when we subtract those, we again get 0.25. So the pattern is 0.25. So what we need to do is take any position and substitute it in for n. So I'm going to take position 1 and substitute it in for n in answer choice A, and I get 0.25. But hold on, let's continue and substitute position 2 in for n. So now I have 2 minus 0.75, and I get 1.25. But notice that the term that I'm looking for in position 2 is 0.5. So even though when I substituted position 1 in the first time and I got the term value, you still need to substitute at least one additional position number into the answer choice to see if it returns the term value for that position. So in fact, answer choice A cannot be the correct answer. Let's go to answer choice B. So once again, substitute position 1. I get 1/4. And notice that the answers are not in fraction form, they're in decimal form. Luckily, 1/4 is one of our benchmark fractions that everybody should know is equivalent to 0.25. So far, answer choice B checks out okay. Let's plug in one additional position. Let's plug in position 2, 2/4, which equals 1/2. And again, we know 1/2 is equivalent to 0.5. And notice that in position 2, we want 0.5. So the correct answer is B. Next question. If n is the position of a number in the sequence, which expression identifies this pattern? So once again, just like in the last problem, we want to take a position number and substitute it for n. If I take position 1 and substitute it, I get 1 plus 20 equals 21. Well, I'm not looking for 21, so it can't be answer choice A. What about answer choice B? 5, so I need to plug the position number in for the exponent. So 5 to the first power, position 1, minus 5 equals 0, because 5 to the first power is 5. 5 minus 5 is 0. Let's try the second position. 5 to the second power minus 5. Well, 5 to the second power, or 5 squared, is 25. 25 minus 5 is 20. Okay, it checks out okay. Let me plug in one more position, the third position. 5 to the third power minus 5. 5 to the third power is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. And don't forget to subtract 5 from that, and you get 120, so it checks out. So the correct answer is B. Number 3. If n is the position of a number in the sequence, which expression identifies the pattern? So once again, we need to plug position number in for n. So if I plug the first position in for n in answer choice A, I get 1 plus 1/3, which is 1 and 1/3. Well, that's not the term that I'm looking for. If I plug position 1 in for answer choice B, I get 1/9. That's not the term I'm looking for in position 1. If I plug position 1 in for C, I get 3 times 1 divided by 9, which is 3/9, which can be simplified to 1/3. Okay, well, so far C checks out okay. Let's plug in position 2. 3 times 2 divided by 9 is 6/9. Let's see, I can divide by 3 and simplify to 2/3. It checks out okay, so the correct answer is C. Number 4. Same thing, if n is the position of a number in the sequence, which expression identifies this pattern? So let's substitute position 1 for n. 1 plus 7 is 8, so it can't be that one. What about position 1 in this answer choice? 2 to the first power is 2. 2 to the, if I plug in position 2 for n, 2 to the second power is 4. 2 to the second power is the same thing as 2 times 2, which equals 4. So it can't be that answer choice because we're looking for a 9 in the second position. What about answer choice? We'll call this answer choice C. 7 times position 1 minus 5 equals 2. Okay, so far so good. Let's plug in position 2. 7 times position 2 minus 5 equals 9, right? Because 7 times 2 is 14. 14 minus 5 is 9. That's the term that we're looking for, so this has to be the correct answer. Number 5, let's plug in. Well, notice that you have the n represents the position number if in the following sequence. Then you have this sequence of numbers. Well, I like to create a table, and let's order these numbers. 1, 2, 3, 4. Some of us can order the numbers mentally. The number on the farthest left is always in position 1, and then it goes in sequence from there. Which expression can be used to find any term in the sequence? So if I plug in position 1, I'm looking for 1/2. Let's see if I get that in answer choice A. 2 times 1 is 2, not 1/2, so I can eliminate A. Answer choice B. 1/2 times 1 is 1/2. So let's see, 1/2 times 1, which is the same thing as 1 over 1, equals 1/2. So that checks out. Let's plug in position 2. 1/2 times 2, well, just think of it. Half of 2 is 1. And that's the position, that's the term that we're looking for in position 2, so it has to be answer choice B. Number 6, Linden Bank pays its customers interest on money kept in savings accounts. The table shows how much interest will be earned on $1,500 for different numbers of years the money is kept in the account. Use the information in the table to determine how much interest in dollars and cents will be earned at Linden Bank in 11 years. So we could continue this table and show how much interest is earned in year 6, year 7, year 8, year 9, year 10, and then year 11, but that's going to take far too much time. So we can create a rule, and then in that rule just substitute the 11th position to find out how much interest is earned. First of all, let's see if this is an arithmetic sequence. Let's find the pattern. So from year 2 to year 3, let's see what the pattern is. So I'm going to subtract those two numbers to get my common difference. So I have $292.50 minus $195. And let's line up our numbers and line up our decimal. I can't subtract 5 from 2, so I need to borrow. Let's see, so this is 19, this is 12, excuse me, this is 18. 12 minus 5 is 7. 18, excuse me, I needed to borrow from the 2. 18 minus 9 is 9. 1 minus 1 is 0. So the difference is $97.50. Let's see if the pattern continues, and if it does, then it's an arithmetic sequence and we can create our rule. So let's subtract the last two numbers. We have $487.50 minus $390 So 5, 7 minus 0, 7. I need to borrow here, so okay, so the pattern we see is $97.50. So yes, it is an arithmetic sequence. So good. We can create a rule. Our rule always starts with a pattern and always has an n next to it. That's pretty easy. So the pattern times n. Then we need to test the rule. So I'm going to plug in position 2 into the rule. So $97.50 times position 2. 2 times 0 is 0. 2 times 5 is 10. 2 times 7 is 14, plus the 1 is 15. 2 times 9 is 18, plus the 1 is 19. And don't forget to move your decimal 2 places. So we get $195. Well, notice that's the term that we're looking for in position 2. So we don't need to make any adjustments to our rule. Here's our rule. Great. So now all I need to do is plug in position 11 into our rule to fill in interest earned for year 11. So when I plug in 11 for n, I get $97.50 times 11. And this is real easy to multiply. 1 times 0 is 0. 1 times 5 is 5. 1 times 7 is 7. 1 times 9 is 9. Add your placeholder before you multiply by the second one, and then just rewrite the same numbers that you just multiplied by 1. So 7, 9, and now we add. And let's see, we have to move our decimal 2 places, right? There's 2 numbers to the right of the decimal, so it goes right here. So in year 11, the answer is $1,072.50 in interest. It's quite a bit of interest earned over time. Next question. Okay, another one of these. If n is the position of a number in the sequence, which expression identifies this pattern? So we want to plug in, oh, now we're not starting with the first position, we're starting with the 4th position, so take note of that. So we're going to plug in 4 into answer choice A, where n is. So we have 8 times 4 plus 0.2. 8 times 4 is 32, plus 0.2 is just 32.2. So, okay, so far answer choice A checks out. Let's plug in position 8 to see if we get 36.2 in our rule. So 8 times position 8 plus 4.2. 8 times 8 is 64, plus 4.2. We're not even close. So we can eliminate answer choice A, right? Because 64 plus 4.2 is going to be 68.2. We want 36.2. Let's try answer choice B. 4 times position 4 plus 4.2. I can look at that and see 4 times 4 is 16, plus 4.2 is going to be 20.2. I don't want 20.2, I want 32.2 for position 4, so it's not going to be B. Let's try answer choice C. So 4, position 4, plus 28.2 equals 32.2. And if you don't know that, just line up your numbers and add them vertically. So far answer choice C checks out. We want 32.2 for position 4. Let's try the 8th position. So we have 8 plus 28.2. Okay, now I know we're going to need to line up our numbers. So let's line them up. 28.2 plus 8.0. We get, and line up your decimal, 36.2. That's what we're looking for the 8th position. 36.2 is right here, so the correct answer is C. Another one. If n is the position of a number in the sequence, which expression identifies this pattern? So we're going to plug the first position in for n in answer choice A. 1 to the second power is 1. 1 plus 4 is 5. That checks out. Let's plug in second position. 2 to the second power is 4. 4 plus 4 is 8. We're looking for 9, so it can't be answer choice A. Let's try answer choice B. 2 to the first power is 2, plus 1 gives us 3. We're looking for 5, so it can't be B. Let's try, we'll come back to answer choice C. Let's see if answer choice D is the correct answer. 1 to the second power is 1. 1 plus 1 is 2. Again, we're looking for 5, so notice I didn't even have to work out answer choice C. I just eliminated the other 3 answer choices to get down to the final answer. So we're good there. Number 9. If n is the position of a number in the sequence, which expression identifies this pattern? Once again, substitute the third position into these rules. 3 plus 18 is 21. We're looking for 7, so it can't be that one. 3 times position 3 is 9. 9 minus 2 is 7. Okay, so far we're good with this answer choice. Let's try plugging in position 4. 3 times 4 is 12. 12 minus 2 is 10. We're looking for 25, so it can't be that answer choice. And this copy didn't really turn out very well. There's lines through the answer choices. Let's see if I can read this. 2 to the third power, 2 to the third power, because we're plugging in the third position for n, minus 1. Well, recall, 2 to the third power is the same thing as 2 times 2 times 2 minus 1. 2 times 2 is 4. 4 times 2 is 8. 8 minus 1 is 7. So far, this rule checks out. Let's plug in the fourth position. So now we have 2 to the fourth power minus 1, which is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 minus 1 is 15. We're looking for 25 in the fourth position, not 15, so we can eliminate that answer choice. Now we're down to the final answer choice is the correct answer. The last problem in arithmetic sequences. Let's substitute 1 for n. We're looking for 6 in the first position, so 1 squared is 1. 1 plus 5 is 6. So far it checks out. Let's plug in position 2. 2 squared is 4. 4 plus 5 is 9. So it can't be answer choice A. Let's try answer choice B. Let's plug in the first position here. So 1 plus 2 is 3. So now we have 2 to the third power minus 2. 2 to the third power is 2 times 2 times 2, which is 8 minus 2 equals 6. So it checks out okay so far. Let's plug in the second position. 2 plus 2 is 4. So now we have 2 to the fourth power minus 2. 2 to the fourth power is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we have 16 minus 2 is 14. We're looking for 15 in the second position, so it can't be answer choice B. Let's look at answer choice C. First position to the third power plus 6 times the first position minus 1. 1 to the third power is 1. 1 plus 6 times 1 is 6, so 1 plus 6 is 7. 7 minus 1 is 6. So far this rule checks out in the first position. Let's try the second position. 2 to the third power plus 6 times position 2 minus 1. Well, 2 to the third power up here we determine is 8, so we have 8 plus 6 times 2 is 12, minus 1, 8, plus 12 is 20, minus 1 equals 19. So it can't be answer choice C because we're looking for 15 in position 2, so it has to be answer choice D.